So welcome to my next webinar on modern Java by example. Thus far, we've been focusing primarily on applications that run in one address space using various concurrency and parallelism models provided by Java Streams, by RxJava, and Project Reactor. Today, we're going to turn our attention to broadening the scope of the applications we focus on by taking a look at how to integrate the reactive streams capabilities in Project Reactor in the context of WebFlux, which is a microservices framework developed by Pivotal that provides the way of integrating reactive programming from top to bottom and end to end. So we're going to revisit one of the examples we looked at a while back, and this is the folders example, and now we're going to look at how to implement it using reactive streams with Project Reactor, and then having it also work in the context of a client-server application using microservices and WebFlux. So let me go ahead and share my screen, and we'll have a chance to take a look at where to find the source code, and then we'll also go ahead and take a look at what the source code looks like. And I'll run the program along the way so you can see how it works. So if we share the screen, you can see that everything's available in my live lessons repository in the folders WebFlux directory. And you'll see there's a bunch of stuff in here. I have some instructions on how to set things up. If you use IntelliJ, it should be very easy to integrate this project directly into your IDE, and it's very simple to use this. This is all based on Gradle. And I should also give a shout out to Sanjeev Kumar, who helped me quite a bit, not only get things up and running with WebFlux, but also helping with some of the more subtle issues of sending back complex data structures across the network from client to server. Naturally, we're not actually using a network today. We're going to be using the loopback device, the localhost device on my laptop, but you get the idea. We could use this in a network, and you'll see how it works in a second. Okay, so let's go ahead and take a look. Here's the main program. This doesn't look a whole heck of a lot different from what we looked at before, with a few minor exceptions. We're going to keep track of the local host where the server is going to be running. I'll show you how the server starts up in a minute. And then we're also going to keep track of the way to contact the server and do various kinds of things. I've also added a whole bunch more options to this example so we can test out many different configurations. We can test things running sequentially, getting the files from the local system. I've set it up so we can do it using sequentially with accessing the content remotely, namely from another server as a microservice. Then we can also do this concurrently, both locally and remotely. And then I also still have my legacy parallel flux example in there. I haven't finished integrating all that yet. So those are what we're going to do, and that'll give us a chance to kind of mix and match and play around with the different options to see how everything works. But before we get too far into running the program, let's go over and see how you build a Flux application. So if you've worked with Spring before, Spring Boot, this is a variant of that, just taking advantage of the integration with Project Reactor to do things in a more fully reactive streams-oriented way, all the way top to bottom, end to end. So here you're going to see we have our folder application, which is just part of the other files that I have here as part of the project. And so the folder application is a Spring Boot application, as you can see from the annotations. And we go ahead and launch the Spring application, and we're going to run the folder application class. So that's how it kind of all starts. The wheels start running. And just for kicks, let me go ahead and start that running in the background. So you see this is running on my local machine, and it's coming up in the Spring container environment, and you can see it's up and running. So that's good. So let's go ahead and go back to the code. Now, if you're familiar with Spring, you know that the way things work are through controllers. And controllers are basically the server side implementation of endpoints that correspond to HTTP requests, GET requests, POST requests, and so on. This particular example is only going to be using HTTP GET requests, but it's very easy to extend it to work with POSTs and other types of requests as well. So let's take a look at the folder controller. You can see here we designate this as being a REST controller, and we have a request mapping that says things that come into this server and at the local host address and are served by this particular controller is the /folders part of the path. And we're going to keep a memoized durant here for fun. You'll see how that works in a second. And then we've got a bunch of we actually have three methods that correspond to different commands that users can invoke in order to access the services offered by this particular microservice. So you're going to see we can search for a word remotely, and we'll look at that in a second. We can count the number of entries like we did before, except now this is a remote call. And perhaps the most interesting call of all, the one we're going to focus the bulk of our attention, is create folder. And create folder is going to go ahead and do the processing to read in the contents of a recursively structured folder hierarchy, a directory hierarchy, which is local to the server. So the server is going to be storing this file system structure. And then create folder is going to be a request made from the client, which is going to go to the server, and the server is going to go ahead and do the operations, all of which use reactive streams, of course, and Project Reactor, in order to essentially begin the asynchronous and concurrent, potentially concurrent, processing of the request. And what makes this particular approach so cool, as you'll see, is that everything is asynchronous. So this is pretty cool. And you'll see this when we run the program. The asynchrony actually goes across the network in a sense. Okay, so what we're going to see here is that we've got create folder. This is going to be driven by a command from the client that's going to designate the root directory and then have the underscore create part of the path, which is going to essentially indicate what operation we want to have performed here. You can see that root dir is the path variable. That's the part right up here. And then we have a couple of request parameters. We have whether we're memoizing or not, and whether we're going to run the processing concurrently or not. So those are things that we can control. And obviously, these are parameters that will be sent from the client to the service in order to carry out this processing. Now, some of this stuff I just added recently, so it's still a bit in flux, but basically the idea is if you want to memoize, then if that flag is set by the client and you haven't gone to the trouble of memoizing something yet, then we're going to go ahead and we're going to essentially go ahead and create the folder, and we're going to get back a memoized durant, which we're going to store locally. And I should probably put this back in here. So we're going to cache the results for the memoized version of this. And what the idea here is that after this is run one time, then the memoized contents will stick around inside the address space of the server. And the next time the client comes around, it'll get back the memoized contents rather than having to go through and do this again. Now, you might argue, is this the right way to write a server these days? And the answer is maybe yes, maybe no. This is obviously putting state into the server, but it's doing it purely from a caching point of view. And obviously, this is only going to work if you have static content. If we have dynamic content, then this particular approach is not the wisest thing to do. But just for kicks, I added that in there for now. If we don't have memoization turned on, then every time a request comes in, it's going to go ahead and call create folder, and that's going to go ahead and start the process running. Now, what's interesting about this call is this create folder call is really just the same call that we've used when we did the test without using microservices and WebFlux. So what it's going to do is it's going to go ahead and go to the appropriate path in the rooted directory structure, and then it's going to go ahead and start to pull everything out, and it's going to create this durant object, and then it's going to have that be sent back, and ultimately it's going to go back to the client. So we'll see that in a second. This is really cool. But this code here is exactly the same code that's running locally if you run the test without using the WebFlux features enabled at all. So it's really a pretty much identical code, which is nice. Okay, let's pop back here for a second. So what we're going to get back from this call, and keep in mind this is all taking place on the server in the microservice, we're going to get back a mono to a durant. And so this particular mono to the durant is then going to be wrapped up by the WebFlux mechanism, and that's going to be sent back over to the client. And this is really cool. So we're actually kind of passing the monos around, if you will, almost as if this was like an object reference in a language like Corba, or a middleware technology like Corba. So that's what the create folder call is going to do. So that's the server side of the world. And keep in mind, the server's up and running. Let's see, I probably, since it's up and running, let me comment that out because that's how I compiled it. We'll worry about the caching stuff later. So essentially, that's the server side. So the server side is going to do that. Now, what's interesting about this, if you take a look at this code, you'll see that there's nothing special here at all in terms of how we're instructing the runtime system, the WebFlux Spring system middleware, to encapsulate all the contents that's going to go flowing back. But I think you might imagine under the hood, it's going to use JSON, and you'll actually get a chance to see the JSON encoded data that comes back. Keep in mind, again, that everything that's created over here is just a good old Java data structure that looks very, very much like we had done before. We have a folder, we have a document, and we have this thing called a durant. Now, the main difference between the code I'm showing here and the code that we looked at a couple weeks ago when we looked at the standalone version of this application is I had to be a little bit more clever about how I wrote the durant data structure to make sure that I had setter and getter methods set up properly so that Spring could essentially encode and decode the contents of a durant object. And we'll talk a little bit about that because that took a little while to get my head around, but it works out quite nicely. So basically what we have here is we have this durant, and the durant is the root of this hierarchy with folders and documents. So a durant is either a folder or it's a document. And if it's a folder, it could have subfolders and documents inside of it. Documents don't have any subfolders, of course. So that's what a durant is. And you can see we've got a bunch of fields like contents, subfolders, documents, and so on. And you'll also notice that the spelling of these things is very carefully designed to be capitalized as a field, which looks a little weird. But once you go down here and take a look at the getter method, you'll see why I did that. So you'll see that for all those fields that I want to have sent back and forth magically by the reflection encoding mechanisms and decoding mechanisms that's provided by WebFlux, I have to make sure that there's a get method that knows how to get that field. So get subfolder returns subfolders. Get documents returns the documents field. Get contents returns the contents field. And then I also have ways to set the contents and set the documents. And those names all have to be very carefully aligned, otherwise the reflective magic doesn't work properly. But other than that, that's all I had to do. So that's basically how the information is going to get sent back and forth. So let's go ahead and take a look at the client side of all this stuff. And that's going to be over here in folder tests. But before we do that, let's just take a quick look at main so you can see how this is all working. So again, what we're going to do is we're going to call run tests with either concurrency true or false, with or concurrent true and false, and remote true or false. So that'll dictate where the computations occur. If you come down to run tests, you'll see that the first thing we do is we call this new helper method called create folder. And once we got a folder, no matter where it came from, then all the other tests look identical. So once we have a folder, we're going to search the folder, we're going to count the entries, we're going to count the lines, and so on and so forth. But the interesting part here is, where does the folder come from? And as you might imagine, it all depends on the flag here called remote. So remote is a Boolean that dictates where we get the folder. So if we're getting the folder remotely, then we're going to go ahead and call the create remote folder method. And in this particular case, we pass in the URL, the host name really for the server, and then we go ahead and pass in the URI, which is how to get to the contents we're looking for here. And then we also pass in a couple of options. Are we memoizing and are we running concurrent? So we get that out of our options singleton. So that's what we do if we're doing it remotely. And we'll go look at the remote call in a second because it's much more complicated than the local call. If we're doing things locally, then this is really identical to examples we've looked at before. So we say folder tests.create folder. This will go ahead and serve the contents out of the local file system, and everything will be done locally. But if we go with create remote folder, then everything changes. Now we're going to get this stuff served from the server, which is running as a WebFlux server with a microservice with that controller we just looked at. So this takes a little bit more ceremony to get things up and running. So we're going to go ahead and use some of the Spring APIs for basically building web requests. And we have this thing called WebClient, which is a builder. So we start building. We add the base URL, which is the host name, whether you're going to find the server running. And then we have to set this thing called exchange strategies. And this is necessary because we could be sending a lot of data back and forth. So let's go ahead and take a look at exchange strategies. That is defined up here. So exchange strategies is a strategy pattern, and it's a builder. And we go ahead and we say, hey, make the codecs increase the max memory size. So we can send up to 10 megabytes in the contents. That's probably overkill for what we need here, but when I first tested it, it was overflowing, so I made it bigger. So we make a bigger buffer, basically, for this. So that gets us our web client, and then we take the web client, and that basically identifies the server and says what the memory buffer sizes are going to be for sending requests back and forth. And then we're going to go ahead and tell that web client, I'd like to make a GET request, please. And not surprisingly, there's also a POST method and a PUT method and all that good stuff. So we're going to make a GET request because that's what we need in this case. We're getting the contents. And then we go ahead and we make the URI. To make the URI, we're going to use this helper class that's also part of Spring called the URI Components Builder. And we say, give me this path, which is basically the operation we saw earlier, which is the URI. And if you go look up here, you can see it's folders works _ create. So that's what we're sending over. We want to add a couple of parameters. So we use these query parameter setter methods, essentially, that go ahead and say, I want memoize to be set to either true or false, and I want concurrent to be set to true or false. We could also have used other ways of doing this, but this is just the simple way I did it. Then we go ahead and build that builder and turn it into a string, and that's what gets passed to URI here. The next thing we do is we go ahead and call retrieve, and that basically goes ahead and says, make this request, this GET request with these parameters baked into the request itself, and then get me back the response, retrieve the response. And now, and here's the really cool part, there's this interesting method called build or body to mono. And body to mono basically says, take the contents that are coming back here as this HTTP response, and then magically convert it into a durant. And that's going to end up using those setters and getters that we looked at. We looked at the durant class earlier. So under the hood, body to mono is going to go ahead and do all that low-level processing for us. So you'll see we don't actually have to write any marshalling and demarshalling code or encoding and decoding code. It's all handled for us automatically by the framework. And you'll also notice what we get back here is we get back a mono. So not only was the server side fully reactive, you'll notice we don't have any blocks here, right? So there's no blocking going on. But the client side is also fully reactive in this respect. And so what we get back from create remote folder is a mono to a durant. And you'll see how that gets used here in just a second. And in fact, from the testing I've done, the actual retrieving of the data doesn't get done until we actually go and block on the client side. At that point, the wheels start in motion. So you'll see how that works in just a second. Okay, so that's basically the overall logic. Now, if we were to pop back over to the main program, then you could see that once we create the folder, remote or not, then the next thing we're going to do is we're going to go ahead and run the test. And we're going to start with search folders. And I want you to kind of keep that in mind when we look at the performance results in a second, because you'll see why there's a big cost, there's a big charge for search folders when we do the remote version. And that's because that's where all the pulling is actually getting done. So it's pretty cool. So we've got the folder application up and running. Now let's go ahead and run the main program. So this is also a cool thing. There's different ways to do this, but this is one way. You notice I'm running my microservice in one part of my IntelliJ application IDE, and now I'm about to run the client side also. So both these things can be taking place simultaneously. I could also crank up another IntelliJ instance if I want to, but this seemed like an easier way to do it. So here's the parameters we're going to give. We're going to run this thing let's start out doing it sequentially. So we'll make concurrent false and we'll make sequential true. And let's go ahead and run everything locally at first. So this is just going to be everything served locally, and we've got debugging turned on. So when I run this, it should hopefully work, and it should serve everything locally. And that'll give you a sense of how long it's going to take in order to do the local serving. And this particular example right now that we're running will be identical to what we did before. So when I'd shown this example before, we didn't have WebFlux at all. And so it just ran locally, just like we're doing here. And you can see the results are what we expect. It searches for the word completable future. It counts the number of entries in the folder. It totals up the number of lines. And you get some results back. Okay, so let's go ahead and now turn on concurrent as well. So now we're going to do what I just described to you locally for both sequential processing and concurrent processing. And what we should see is that the concurrent versions are faster, which is what you'd expect, because I've got a quad-core, hyper-threaded MacBook here, and so we should expect to speed up. And in fact, that's what you see here. So you can see that the concurrent version running locally took about 274 milliseconds to search the folders, whereas the sequential version was about triple or so, a little bit more than 3 times slower, which is what you'd expect with the number of cores I've got. All right, now let's have some fun though, and let's go ahead and turn on the remote version. So let's turn off sequential. We don't really care about sequential, so let's make that false. And let's go ahead and for the moment, let's turn off local. So it'll just be going remote, and let's turn on remote. So remote is now turned on. Memoization is turned off, so it's not going to cache anything. And now let's go ahead and run this, and hopefully it'll work. You can see that the server is still up and running. And in fact, it does work. But one of the things to note here is that create folders, it comes back pretty fast, not super fast, but the time is really spent in search folders. And that's because that's the thing that's really doing the bulk of the work and moving the data back. And you can see it also gives the same result. So what we do in this particular scenario is we go over, the client makes a call to the microservice. The microservice goes ahead and creates the folder and then sends the contents of the folder back to the client. And then the client uses that folder that it got from the server and does all the processing locally. We can also run this program where we send the work to be done over to the server. So there's a couple different ways to do this. One is to move the computation to the server, in which case we do the computation remotely and then get the result back. So that's server-side computation. The other is ask the server for the content and then do the processing locally. So we've got all the different bases covered here. What we're going to do now is we're going to go ahead and run another configuration where we're going to have both the local and remote cases going on at the same time. So we turn on local and remote. Memoization is still off. And then this will be able to give you a sense of what's the overhead of doing the remote calls. And keep in mind, remote in this case is on my computer running in another process. So it's not really across the network. And as you can see here, as you might expect, the remote operations are going to take longer in order to do the computations here. And you can see that in this particular case, creating a folder locally creating the folder remotely was pretty fast. But then searching the folder remotely took a lot longer. And again, that's what you'd expect, because that's what's paying the cost for transmitting the data over there to the client. So that's, and I'm sure there's many other things I could do to speed all this stuff up by using other more advanced features. But I just wanted to kind of get a quick way of being able to demonstrate how to integrate the microservices capabilities of WebFlux on the server side with the program we have on the client side. Now, another thing I want to do here is I want to crank open my terminal and show you what actually comes back when you make a request to the server. So now what we're going to do is we're actually going to run this from a command shell. So I'm no longer in the confines of my program, my client-side code I was just showing you. And instead, we're going to use the curl command line utility to send a GET request to this URL, which is basically to include the localhost 8080. That's how to contact my server. And then we give kind of the path portion, which is folders, works, that's going to find the appropriate location. And then we give the operation, which in this case is create. And we're going to give some arguments. We're going to say memoization equals false and concurrent equals true. So it's going to do the concurrent processing on the server side. And then we're going to run the result through the JSON pretty printer. And you can see we're up and running, off to the races. And this is going to run for a while because there's a lot of data being sent back from the server to the client. Probably not the world's best microservice design to spew back this much data, but I was just having fun to see if I could kind of torture test the WebFlux and see what it did and how it behaved. And it works fine, which is really good news. Again, probably not the best design to send all the data back in one fell swoop. But in a second, you can see we're done. And you can also see how the pretty printer kind of organized the JSON to make it easier to read. So you can see that, for example, the works was the top level directory. It's a directory, so it has no contents. It has 1,893 subfolders and documents in it. It has no documents in the top level directory. Here's the path name that it's got. And then you can start to see like what's in the JSON. So underneath this was a POSA directory and a live lessons directory. You can see the POSA directory had 784 elements in it. And then it also had some documents, like a README file, for example. And I won't go through and bore you to death, but if you were to look at this pretty printed JSON, you would see all the contents of the data that I just downloaded. And what makes that so cool, as I mentioned before, is there's really nothing in the code that explicitly does the encoding and decoding of that Java object into JSON and then from JSON back to the Java object. All of that magic is handled automatically by the underlying mechanisms that are part of WebFlux. In particular, if you go over here, you can see on the client side, it's the body to mono call that obviously under the hood is going to use reflection in order to take the HTTP response and then put it into the format that's described with the Durant class. So that's how we convert JSON back to a Durant object. And then on the server side, the way this is done, of course, is just by describing the information here and saying that create folder is part of a RESTful controller and it returns a mono to a Durant. So all that stuff is just kind of handled magically for us under the hood, which is really cool. There's other things that we could play around with, but for right now, I think that's where I'm going to stop. I'm still having fun experimenting with these features. And I have to say, it's remarkably simple to get something up and running, and the ability to do reactive programming kind of from top to bottom and end to end is very nice. And it allows you to think reactively without having to stop and do something different when you reach a network boundary, which is really the whole point of this WebFlux approach. So let's go ahead and stop and take some questions. Let's see. So can WebFlux be connected into a plain Java 8 stream? Yeah, I believe it should be. I haven't tried that yet, but given that streams are baked into support in Project Reactor, you should be able to do that. I'm not sure if you can return a stream the way you can return a mono or a flux as a parameter, as a return value from the methods. I haven't tried that yet. I might actually be a bit surprised if that worked, but it certainly works nicely with monos and fluxes. In this case, I'm using monos, but I could also be using fluxes. Oh yeah, let me. I forgot to show the memoizer stuff. That's a good point. Let me go back and share my screen again, and we'll take a look at the memoizer part. So for the memoizer, let's go up here and let's set M -m to true. So by default, it was memoization was turned off. And what we're going to do now is we're going to run this thing, and obviously we're going to have to run it a couple times to actually get a benefit. So what's happening here is when memoization is turned on, that flag is set. It's passed over as a Boolean to the server, to the service, where it's then used to basically memoize and stash the result. And so conceivably, the next time we call it, we're getting the memoized version of this. And if you look, it's a little bit faster. So I think the overhead here is probably in sending the JSON back and forth, not in the time required to actually create the folder on the server side in the first place. But that's an example of being able to turn memoizing on and off. And I probably need to play around with some other flags to really get it optimized the way it ought to be. But that was just kind of a quick and dirty way of showing off the memoization technique. Now, again, you have to decide whether or not that's appropriate for your server. In this particular case, it's just a cache of static content. So it's really no harm. Obviously, if the underlying content was changing, you wouldn't want to memoize it in this way without some more sophisticated cache algorithms, like either updating the cache as things changed or being able to detect that the cache was out of date and then refresh it. And that would require extra work, but I think you get the basic idea. Let's see. In this implementation, there's no need to use the block. So there certainly was no blocking on the server side. If you go look at the server side, one of the cool things about using WebFlux, which is really why I wanted to play around with this in the first place, was that you can write code that doesn't need to block. It just basically gives back a mono or a flux. And then when that data is actually used, then the content is pulled across. So it's lazy evaluation. Now, if you look at the client code, I eventually did end up blocking because I wanted to get the results back. I didn't want to just wait forever. But you don't have to do that. You could obviously design your client to not have to block explicitly either. You could organize that using all the other techniques we've talked about before with our async tester and so on. If we're pulling from a different application, then the memoizer won't work. So again, I don't know. I haven't tried that. I haven't tried having multiple clients in that case, but I would think that as long as they're all expecting the same data, they should be able to get it back. But I'll play around with that and see what the deal is. So I turned on the caching for the memoizer, so it should just return whatever had been cached when it was called the first time. Let's see. Could the server stream the data back to the client so the client can start working on the task concurrently instead of having to wait for all the data to be returned? Yeah, absolutely. That certainly could be done as well. Like I said, this particular design is just to see if I could retrofit an existing application quickly to try it out. In real life, you probably wouldn't want to send over the gigantic JSON encoding for the entire directory structure. You'd probably want to give it back in dribs and drabs with some kind of iterator-like mechanism to make it faster. Is there an equivalent of WebFlux for database access? Undoubtedly there is. I don't happen to be a big database person, but I've got to believe that someone has built that into the mechanisms that are available now. So I would recommend going out and searching to see whether popular databases, Cassandra or Mongo or whatever people are using these days, would provide the requisite support for being able to do reactive searching. I don't happen to have that knowledge. Sounds like there's some drivers that support reactive APIs for Mongo, which is not unusual. I would not be the least bit surprised if in the not too distant future, most of the stuff that people have out there comes out of the box with good support, especially in the Spring environment, good support for reactive features, because they're really, really useful. And that ability to have the reactive streams model top to bottom, end to end, is a really nice paradigm. So I'm going to continue to have fun and play around with this stuff. We'll probably go and take some other examples, maybe more interesting examples and more representative examples than this one, and continue to retrofit them to use the WebFlux approach I've got some other cool ideas for other kinds of things in a more kind of publish subscribe like model that could be useful. But if you guys have any other questions, I'd be happy to talk about those and see some other examples. Another question is, see the usage of Flux over Mono. Sure, yeah, that's something else. I'll be happy to add that in future versions. This stuff is really easy to use. So once you got the basic framework like I have here, it's trivial to take it and just play around with it and make changes and do whatever you need to do in order to make it work for you and your particular configurations. I've also got another variant of this that Sanjeev helped me do. This was actually just a Spring application as opposed to a WebFlux application or Spring Boot application. And that demonstrated both the get and the post call. So in that case, it's an enhancement to the image stream gang application so that we can run a bunch of tests and then we can go ahead and get the results from the tests. So it demonstrates both post and get. And I'll, excuse me, probably play around with that a little bit and see if I can make it work now with WebFlux, now that we have the WebFlux infrastructure in place. And that may be a way to show off some of the other features. One of the really cool things about the image stream gang application was we were passing around basically maps. So very rich data structures, which again are handled out of the box quite nicely by the WebFlux and its encoding and decoding mechanisms. Okay, well, thank you guys again for coming. Let's see. How about doing a poll for future sessions? Yeah, that's a good idea. I'll try that. I can't promise that I can learn everything people want me to show, but I'm certainly happy to do what I can. There's certain things that I will be happy to present examples if others are willing to pitch in and help get things off the ground. That would be particularly helpful for stuff like the databases, where I just don't have that much database knowledge. But if someone can help work on that, I can then present it and obviously give credit where credit's due. I really appreciated all of Sanjeev's help for this project. And it's fun to learn new things and then explore and demonstrate how they work. I think it's also helpful to have working code that you can play with on your end in order to see how these things apply for you. So yeah, that's a great idea. I'll go ahead and do a poll on my YouTube channel and we'll see what other topics people would like to see. Well, great guys. Thank you again very much for coming and I'll look forward to talking to you soon.